So we've been talking about difference testing with means, but what if you don't have a mean? What if instead you have a proportion? We can look at a one sample test of proportion. This is a lot like our one sample Z or T test in that we are testing, is our sample different than the population? So there is a significant difference between our sample and the overall population. Our equation looks like this, where pi does not mean 3.14 and p does not mean probability, because in statistics we're sometimes jerks and we like to use the same symbol for multiple things. So you just have to kind of know this one. P in this case, in this equation, means the sample proportion, pi means the population proportion, and n is a little n, it is our sample size. So here's an example. We have a CEO of a large company that says 80% of his customers are very satisfied with the service that they receive. To test this claim, the local newspaper surveyed 100 of his customers using random sample. Among the customers, 73% say that they are very satisfied. Based on these findings, can we reject the claim of 80%? We're going to use 95% confidence. So 73% is different than 80%, but we want to know, is it statistically significantly different than the two? So we are going to go right over here. Our research question is his claim about the population different than the sample that the newspaper took? The null and alternative are the same as we've been doing. So we're going to say the population is essentially equal to the sample. So the population mean and the sample mean, those distributions are the same. We're also, for the alternative, we're going to say, are they not equal? We're not curious if they're higher than lower, we're just, is it the same or is it not the same? So this would be two-tail. 95% confidence, which means our alpha is 0.05. The test we need is a one sample, because it's one sample compared to a population, proportion test. So now we need to calculate that test. So step one is to get all the information into something that we can use. The population proportion was 80. So he said it was 80% satisfied. The newspaper found that 73% were satisfied after sampling 100. Now we have the population sample, we have the population size, but we don't need it for this equation. So that was extra information. So we're going to plug these numbers in, watching which one goes where, into our equation and solve it. So I'm going to put 0.8 here, here, and here, and 0.73 here, 100 here, and then solve. So press pause and solve the equation. Press pause and solve it. Pause it. When we calculate that, we get a z equal to 1.75. So we need to know, is that 1.75 significant? Based on what you know about the z distribution, you might already have a guess, but let's double check. So I'm going to go to Google and I'm going to say Z to P calculator, and I'm going to click on this one, Soci Statistics. I can type in my z-score at 1.75. We have a 95% confidence level. This one is two-tailed. I hit calculate. And it tells me that my p-value is 0.08, which is not significant. So because it is larger than 0.05, it is not significant. So it is not significant, meaning going back up here, I fail to reject this. So if it is not significant, then I'm going to say I fail to reject the null. There is no significant difference between the population and the sample. Since we fail to reject the null, it is possible that we made a type 2 error.